Okay, so this is the first video in a series of videos that I hope help you learn some math. It'll be a daily quiz video. So what I show you today, I'll be doing 3 problems. I'll be doing 5 problems at a time on the same topic. And by the time you get to the 5th one, I hope you have mastered the mechanics in short-term memory. And our challenge will be to keep it in your long-term memory. So what I plan on doing is writing a worksheet for Monday. It'll start with these first 3 problems. And then I'll try to see which ones folks are getting right on the last. And we didn't get a lot of right problems. We got a lot of gaps in mathematical aptitude here from previous years of study that we got to fill. And there was some decent progress, but there were also some major gaps that need closing. And so we got to work on all of that. We got to keep moving in the right direction. So this is probably the most famous Pythagorean triangle, the 3, 4, 5. And I hope you can see opposite. I'm always going to draw them in standard form in the coordinate system. And I'll probably at the algebra 1 level until at least midterm, keep them in the first quadrant. This is the first quadrant. This is the second. This is the third. This is the fourth. Okay. I would have hoped you would have had that from pre-algebra, but based on the first test, I guess maybe you had pre-algebra in front of a TV screen or a computer screen, whatever. All right. So if you square these numbers, you get this relationship. And I hope that if I tell you, you don't know that one, that you would add, right, to get this. And then you would take the square root of that number because this is the side of a square. Okay. If I didn't give you this one, I'd hope you take the biggest minus one of the littler ones to get the area. And of course, how do I get this square root area? I take the square root of that, and that's why that's a 4. And so that's hopefully enough said on that. I'm going to do 5 problems now. Each of the triangles will be drawn in standard position, and you do the work. And if you get 2 or 3 in a row, skip ahead. All right, here we go. But a lot of people left this blank. I don't understand that. All right, so let's go with an X that we don't know. Let's take a Y, let's call this 7. Let's call that 10, and you tell me what X is. All right, so I'm gonna go over here and I'm gonna play with that. Well, I'm gonna make it a little smaller so it stays on the board. I see this. I see this. I know what this has to be now. And therefore I know what that length is, and that length is the square root of 51. Yeah, it's one of them down. Gotta do 4 more. Yeah, I think maybe I won't keep it in standard position, but let's see. At least for the first 3. But what do I have? Let's say we want to find that one. Let's make this, how about we make this 6 units. Let's make that 7, and let's find out what that is. All right, so I'll do it down here. I'll do it over here. Boom. All right, so 7. I think we're looking at that. 6. Oh God, shoulder problems. 36. Well, it looks like this has to be 13. So what is this side length? Square root of 13, a little bit less than 4. Square root of 16 is 4. Okay, didn't seem like it was drawn too well to scale. That's okay. Let's try another here, and then I think I will throw them in different quadrants. So let's go with, okay, let's go with 5 and 5. I already know that answer from trigonometry, but let's find it anyway. All right, that's the big one, right? So how about if I take a little shortcut and call that 25, a little shortcut and call that 25, then this has to be 50, and therefore that's the square root of 50. And we've been working with that elsewhere on the test, so I might as well do it. Square root of 25 times the square root of 2, which is equal to 5 root 2, something else, a skill you need to learn. So no reason not to show it. But at this stage, I would have accepted the square root of 50 on the test. And if I put a little circle around it, it means it's okay for now. Maybe after midterm, if you didn't say 5√2, which I knew to begin with, because it was a 45 degree triangle, which has certain ratios, they were always the same. I think I was going to keep track here. I think that was the third one. So let's go to another quadrant. Let's make this -5. Let's make that -6. And you tell me the dotted line, and that distance has to be positive. So the hypotenuse is always positive. So what do we have? Well, nothing different really. You're squaring that, so you're always going to get a positive area. You're squaring that, you're always going to get a positive area. And the 90 degrees over here now, so that's the hypotenuse. So 20 and 30, so this has to be 61. It's Mr. Big, right? Here's your 90 degree angle opposite the 90 is the longest side. So what is this dotted line? Square root of 61. So it's not that much different. That was the second quadrant. Let's put one in the fourth quadrant. Let's put one over here. Let's find that x value. If this y is -7, and let's make this 90 degree. Let's make this 9. Remember, the hypotenuse is always positive. The hypotenuse is always opposite. So now we can come over here. We can maybe make the triangle a little smaller. But 9 units, here's your 90 degree. That's not a very good drawing. So let's finish it up with something a little better. I think that's pretty good. Okay, that's replicating that. We're trying to find this. We know this area, 49. We know that area, 81. This is the big one. This is the big one. So 81 minus 49 is 32. So 32 is the area. So the square root of 32 is that x value. We'll accept that for now. But here are the important squares. 1, 4, I don't need to write it. 1, 4, 9, 16, 25. Oh, 16. 16 goes into 32. So we have the square root of 16 times the square root of 2 is the same thing as the square root of 32. But that's 4√2. And I've asked you to memorize root 2. I don't, maybe one or two you have. But root 2 is, I'll keep showing it, 1.41. It's on your memorization sheet. And so that's actually a pretty good way to get an approximation for that without a calculator. Not going to do it. Okay, so that's going to be your first question, missing side length. And if I come up with a blank on that, on Monday, I got to assume you're not doing your homework. And I'll just have to write your advisor. Hope everybody does homework, because I haven't really assigned it in such a way as I'm assigning it now, but I'm assigning it. All right, so question 2 on your daily quiz on Monday will be factoring, which is a fancy way of saying writing sums and differences as products. So here's a sum and a difference. 2 plus 3 times 4 plus 5. Now that is in factored form because it's a product. I can write it as a sum. 2 times 4 is 8. 2 times 5 is 10. 3 times 4 is 12. And 3 times 5 is 15. And this is called a trinomial. Well, it's not a trinomial because you can put all these numbers together. 18, well, it's 45, right? This is 5 and this is 9. So when you add this up, you also get 45. Okay? Just to show you the mechanics of a binomial two-termed expression times another two-termed expression, 2 things times 2 things give you 4 things. But the problems we're going to be working with, which are probably the heart and soul of algebra 1, is this problem. You see it more than anything else. How to change something, a trinomial, which is something like this, plus 2x minus 15, into a product. And there's some real patterns here. First thing you do with a trinomial is make sure there's nothing common, because that's your first rule of factoring. I'm not giving you anything common. I'm just giving you some basic trinomial factoring so we can start getting better at it. X squared is easy to show as a product. Put x in the front parentheses and in the front of the second parentheses, and we have established that. Now there's a pattern here where what you'll find is we have to get something times something to get us that last term. Right? That's what I did in the last problem to get the last term. Right? 2 plus 3 times 4 plus 5. We just keep saying it. But that's the last thing I did. Right? Was multiply that times that. So to get minus 15, I need either a 1 times 15, a 15 times 1. Well, let me do it this way. We have to have two numbers that multiply out to be negative 15, but those two numbers are also going to have to add up to 2. All right, so you got 1 and 15, and you got 5 and 3. Which of those combinations can we do a little addition or subtraction to get the number 2? It's obvious that it's got to be 5 times negative 3, because 5 plus negative 3 adds up to 2. That's what you're trying to get your brain to see. And let me square this up a little bit. Okay, so we have found it. It's addition of 5 and subtraction of 3. Now this is supposed to work for any numbers. Any numbers. So let's put the number 10 in here. See how it works. 10 squared is 100. Plus 2 times 10 is 20. Minus 15 is 100 plus 5. 105. If I put 10 in over there and I don't get 105, then we're all done for the year studying algebra. Unless I made a real careless mistake, which is possible. Always happens. 10 plus 5 is 15. 10 minus 3 is 7. Using the distributive property, 7 times 10 plus 5 is how you want to do that in your head. And that's 70 plus 35, which lo and behold is 105. So I don't care what numbers you pick 0. That's gone. That's gone. You get minus 15. That's what we're practicing right now. And that was our first one. Here come 4 more. You pause the video. See if you can get it. So let's look at x squared. Let's look at minus 10x plus 21. We want to write that as a product. Okay. So pause the video. What did we talk about before? Said we got to find two numbers that multiply out to be 21, but those two numbers have to add up to minus 10. That's really what's going on here from a mechanical level. So you look at the factors of 21, 1 and 21, 3 and 7. I can't think of any others. And I got to get something to add up to negative 10. Well, if these were both negative, they add up to negative 10. So I have a feeling it's x minus 3 times x minus 7. Now, what's a good number to pick? I should have picked a better number before. I picked one at random. I'm going to let x equal 7. Because what's 7 minus 7? 0, and 0 times anything is 0. So I'm going to put a 7 over here and see if it comes out as 0. 49 minus 70 plus 21. 1 and 9 makes 50. And 50 minus 70 plus 20, 20 and 50 makes 70. 70 minus 70, lo and behold, yeah, both sides equal 0 when I pick a 7. Boy, geez, I wonder if that means that if I ever set this equation to 0, and I know this skill, I can set this to 0, and not only does 7 probably get me a 0, maybe there's another number that could get me 0. So we might even start solving some equations with this skill. So let's practice this skill again. Let's look at x squared. How about we look at minus 9x? And how about we go with minus 22? And you stop the video, push the space bar, and you try it, and I'll just keep going. I think we can start with x and x. I'm looking for two numbers that multiply out to be negative 22, but those two numbers have to add up to minus 9. Oh, it's either 1 and 22, some kind of combination of 1 and 22, or I guess 2 and 11. Oh, you know, if I made the 11 a negative and the 2 a positive, and I added those up, I think I get that number. And I think if I make the 11 a negative, and I multiply these 2 times, I think I get that number. I think I found it. I think it's x minus 11 times x plus 2. That's our third one. 2 more. And then a quiz on Monday on this topic. Let's see, how about we do x squared plus 4x plus, no, I can't, that's too small. 4x, let's go with minus, let's see, minus, don't get some fairly large, minus 60. Yeah, that's a good one at this level. Okay, so pause the video, you go after it. 2 numbers that multiply out to be minus 60. And those 2 numbers have to add up to 4. Well, I know 1 times 60. I know it's even. 2 times 30. I know that's even. So 4 times something gets me 60. 4 times 15. Yeah, it looks like that because I'm taking 2 out of that. I can take a 3 out of this and a 5. I'll take the 3 out. So that leaves me with 12 times 5. And something, yeah, I think that's fine. Yeah, 50, 60, yep. And then I can take a 5 out. And 5 times 4 is 20 times 3. So 20 times 3. I don't know if I'm missing any there or not, but yeah, the one that works. This is the one that works, which is 10 times 6. So let me see if I can streamline this more easily. So 1, 2, 3, 4. I got a lot of combinations here, huh? 6, and then I think we go backwards. 6 times 10, 4 times 15, 3 times 20, 2 times 30, 1 times 60. Don't know if I got them all, but I mean, I can stop right here. I think I probably should have gone back to grade school, you know, 3rd and 4th grade when you did factoring trees. I was trying to avoid that. So what makes negative 60 and add up to 4? Well, the positive's got to win out, so 10, and that's got to be the minus, right? So minus 6, got to be that, because 10 times minus 6 is that, and that's true too. So it looks like it's x plus 10, x minus 6. And if I said, when does that equal 0? I would hope that you would put the critical numbers of minus 10 and positive 6 in there. Because we're going to be using this for graphical purposes down the road, but we can't use it until you get it. All right, so I think that's my 4th one. Let me give you one more as a practice. All right, so let's look at x squared. How about we go plus 10x. All right, and let's go with minus 28. Is that good? No. Minus, oh, brain is tired. Minus 24. Yeah, that's fine. All right, push the stop bar there, the space bar. Okay, I'm just gonna do it this time. So I'm hoping you got x and x, and I'm hoping to find the 2 numbers, which are 2 and 12. Right, and if I want to get positive 10, that's positive 12, and that's minus 2. And so what I guess I just did there was show you that hopefully with enough practice, you don't have to actually go over here and do this, right? Do that process. But if you're struggling with it, then use that as a little crutch until we get better. And that's our second question. Third question. I teach you how to graph parabolas more easily than what you've been doing. So we have 2 types. We have the positive a, x squared plus bx plus c. And we have the negative a, where a, you know, a negative number. I guess I'm not showing this properly. But we have cup shape up, and if the a is negative, so if you had minus 2x squared, that's cup shape down. If you had positive 2x squared, cup shape up. That's what I was getting at. All right, so I'll give you one. I'll show you the 4 steps that you need to do. We're going to do 5 in a row, and I hope some of you get it right on Monday. All right, right, so let's go with 2x squared plus 20x minus 7. All right, step 1, positive. Cup shape up. Okay. Step 2 is a little unconventional, and I'll show you why it works though, because I think it's going to help us in the long run. The middle term is positive. This is your y-intercept. And that's your y-intercept. This means it's on the increasing side. You follow graphs from right to left. As I go to the right, the hand goes down and it goes up. That mimics the -3, -3 gets you 9. This one is -2, -2 gets you 4, right? That area is going down. Whereas on a number line, as I move from left to right, my x's are getting bigger. Well, moving in this direction, if I do this, right there, you can see that these x's are getting bigger. I'm moving in that direction slowly. So I'm basically coming down and moving over. So I'm always moving over. I don't know how to describe that any better. But that's the decreasing side, that's the increasing. You're on the increasing side. So I can immediately put 0, -7 there. All right, and then all I have to do is get the vertex. How do you get that x and a y? Well, you got to get the x first. Get the x first. You need minus b over 2a. I already know it's to the left of 0. It's going to be negative. So I don't even have to do that. I just divide 2 into 20, get 10, cut it in half. And I know it's negative. But let's do minus b over 2 times 2, which is minus 20 over 4, which is what I told you it had to be. And then you put the -5 into x. It's a placeholder, right? So you're just dropping it in, dropping it in. I hope you can see -5 times 20 is -100. That has to be half of it and the opposite. If it isn't, you made a sign error. -5 squared is 25 times 2, it's correct. -7 gets you -50, -7, -57. Some of you are almost getting it. We're just a little bit off. Forgetting one little part of that, perhaps. All right. And this is going to allow us to eventually write things in graphing form. It's easier to write this in graphing form right now. You can take the 2, you can write x plus 5 squared minus 57. That's going to eventually let us get the roots very easily with inverse operations. But right now, I'm just going to do 4 more problems of writing those in graphing form. And I will do it 2 ways. The way that I do it, which I think is the quickest and easiest, and the way that maybe you should. So let's look at another one with positive. Let's look at 3x squared. Let's look at minus 12x plus 9. Okay, I know cup shape up. So let's do that. That's step 1. It's got to be, if you get 2 out of the 4 parts, I can start giving you half a point. Okay, so if you got the cup shape up, that's a quarter point. I'm not going to be giving it to you, but in my mind, that's what that's worth. Finding the vertex. It's probably easier for you right now. Minus b over 2a. That's the critical number. So that's positive 12 over 2 times 3 is 6. I now know that's 2, which means my y-intercept is over here at 0, 9. Okay, maybe that's the way you should do it. I knew I was on the decreasing side, which is the left side. So I know that's 0, 9, which means that I know that this has to be positive. So I don't have to worry about the signs. 3 goes into 12, 4, cut it in half, 2. Okay. And then I'm 1 step away. I find that to be just slightly quicker. But either way, you got to put 2 in. And if you put 2 in and you're not getting 12, get some math help. Minus 24 plus 9. Okay. You'll find that whenever you add the first 2, it's always half the middle or the opposite of the first term. That's a little shortcut down the road. Minus 12 plus 9, -3. Okay. That's going to be worth 2 points on your test. Sketching a graph, 2 points. So I have to give a half a point just for knowing it's cup shape up from now on. And another half a point for finding the y-intercept and putting it on the correct side. A half a point for finding the x. and a half a point for finding the y. Give you some credit for learning, right? I hope you can get to the point where you get all of it. All right, so that's our second one. Here's your third practice. And I'm hoping I see some right answers on a daily quiz, that this is an effective way of trying to move forward. All right, so let's look at minus 2x squared plus, how about we go with 16x minus 5 for a half a point? Bingo. I know my y-intercept's on the left because it's increasing. I can show, I've already showed you a couple of times. Doesn't mean it's resonated with you yet. Okay, how do I find the vertex? Minus b over 2 times a. Don't forget the minus sign. And a negative into a negative is positive. That's nice. So therefore, we're looking at 4. That's the most important x value. If I put 4 in, I get negative 32. If this isn't 64, I've done something wrong. 4 times 16 is 64. Minus 5. Half of 64 is the opposite of that, which is 32. Minus 5 gets me 27. It's got to be worth a half a point. And where's the y-intercept? I told you it's on the increasing side. Well, if x is 4, then yes, that's got to be to the left of it. And that is the y-intercept. There's your third one. 2 points if you get that. Because it's going to be on every test the rest of the year. The question is, when do you want to start getting it right? Takes effort. Let's try this. Minus 3x squared plus 24x minus 7. Okay. Yes. Already had that in my mind. All right. Let's make this. No, you've already paused the video probably. So let's leave it that way. So again, my y-intercept's going to be on this side, but let's get the vertex. Minus b over 2a. Can I write 2 times that? This little shortcut there. There's 4 again. How do I find the y value? I plug it in. 16 times minus 48. This better be 96. 4 times 24. 4 times 20 plus 4 is how you do that in your head. There's your 80 and 16. There's your 96. Minus 7. That's half of that. So therefore, this is positive 48. Minus 7 should get you 41. Okay. And now, again, vertex, y-intercept. You want to find a y-intercept of any calculation, put 0 in for x. 0's to the left of 4. And if I put 0 in, that's my y-intercept. Now, if I went 4 units this way, 4 units that way, that's a quadratic change of 16. I don't want 16. I want to go from 41 down to minus 7. That's minus 48. And if you divide these, minus 48 by 16, there's your negative 3. Just thought I'd throw a little conceptualization your way. So there's our fourth one. Let's do one more. Let's do a 2x squared minus 20x plus 9. Pause the video. Last shot at it. Hopefully. Cup shape up. Boom. Vertex minus b over 2 times a. 4 into 20. 5. 5 squared. 25 times 2, 50. Therefore, I really know I'm looking at minus 50 and plus 9. But let's do it out. 5 times minus 20 minus 100 plus 9. When I put those together, I get minus 50 plus 9 minus 41. Where's the y-intercept? X is 0 to the left of 5 on the decreasing side. Boom. So 0 gets me that number as a y-intercept. Good luck on your quiz on Monday. feel like giving you those three problems again, just to see if you can handle them. But, yeah, why not? Let's see if you speed up here. Missing side. Okay, 6, 10, factor, x squared minus x minus 20. And sketch, 3x squared minus 6x plus 7. Now you can pause the video, try all three. I know that that's 100 minus 36, which is 64. Oh, this is one of those. Accidentally hit the 6, 8, 10. If this is 3, 4, 5, all I did was double the side lengths. Didn't mean to. 6, 8, 10. Didn't mean to do that, but it did. And so that's what that one would be. And x squared, two numbers that multiply out to be negative 20 and are 1 apart, negative 1 apart. So it looks like it's x minus 5 times x plus 4. That's what you should have gotten there. And over here, cup shape up. Nice. Yeah, I'll do it the way that's probably easier for you. So 6 divided by 6 is 1. So therefore, I put in a 1. That's got to be 0.7 here without, spending much more time on it. 1 gets me 3 minus 6 plus 7. I'm seeing what I want to see. So minus 3 plus 7 gets me 4. One last practice on the three problems. And that is going to be a quiz coming your way very soon. All right, so put an end to that. We'll pick 3 new problems later.